Hi, I'm Brooke, and in this video, I'll be explaining the ideal free distribution model. At first, I was initially confused on how the assumptions were related to the graph, and I struggled to interpret the graph of fitness versus population density and also the isodar. So this video will explain how to interpret those graphs, and it'll use giraffes as an example. So the ideal free distribution model is used to describe the distribution of organisms within an environment based on the availability of resources in that environment. The model suggests that organisms will distribute themselves in a way that maximizes their fitness. And the ideal free distribution model makes 5 assumptions that will each help explain the graph. So first, it says that individuals will attempt to maximize their fitness. Individuals are equal competitors. Individuals are free to move at no cost, meaning that they can move from habitat to habitat. Habitat locations have different resources, and fitness is negatively density dependent, meaning that as the density in a habitat increases, the fitness will decrease. Now, knowing this, let's look at the scenario and see how it fits the ideal free distribution model. So let's say there's 2 patches of land. Patch A is large and has a river running through it. Patch B is smaller and doesn't have a water source nearby. So these 2 habitats differ in resources, which fits with the ideal free distribution model. And as freely moving giraffes first occupy the patches, they're first going to pick patch A because it has the better habitat quality and it's richer in resources. And as more giraffes come, the density of patch A will increase, and there'll come a point where the poorer resources of patch B actually provide the same fitness as the crowded patch A. So let's say 3 is the maximum number of giraffes that optimize that fitness. Well, when another giraffe comes, it's going to want to go to patch B because it has equal fitness in patch B. But if this giraffe were to come to patch A, it would have a decreased fitness. And this is the graph of the ideal free distribution model. And the rich habitat is always going to be on top of the poor habitat. So this is kind of what confused me when we were first looking over it in lecture. But basically, the dashed line just shows that at different densities in each habitat, there's a point where the fitness is equal. So at this dashed line, the fitness of the poor habitat is equal to the fitness found in the rich habitat. However, the density of the poor habitat is going to be lower than the density in the rich habitat. So it's going to have a fewer number of competitors in the poor habitat compared to the richer habitat, but the fitness is still the same. And then if you plot the densities of each habitat against each other, you'll see that it creates a linear relationship, and this is called an isodar, meaning that both habitats have the same measure of fitness. As the density of habitat 1, or in this graph, the density of habitat B increases, so does the density in habitat A. And basically, the main idea of the ideal free distribution model is that even though you have 2 habitats that have different resources, there's a point where the fitness is the same in each habitat because the population densities are appropriate at that specific point. And it's also important to remember that in real world situations, many of these cases may not always perfectly adhere to the assumptions of the model due to factors such as competition and predation.